Hello, everybody, and welcome to episode 2 of the Hot Path Show. I'm Johnny, joined by my other co-host, Tobias. You disappeared there for a second, but welcome in. How's it going, Tobias?
It's
Welcome
going
to
good,
your
thank you.
awesome, yeah. Welcome to your debut on the Hot Path Show. So excited to have you here today. So everybody, welcome into the Hot Path Show. This is a weekly live show where we discuss solving problems in game development using data-oriented design. So I have a couple rotation of co-hosts here. So Danny was on last week, and then we have Tobias on here today. And I'm excited to get into the show today. So I'm going to be taking over for the main topic of today's show, which is going to be Unity's a deep dive into Unity ECS transform systems. The reason that I wanted to do this is because there are so many, awesome and fun topics that we can get into on this show that all kind of like build off of things with the transform system. So I think this is a good, just kind of fundamental episode that we can have kind of early on in the show run here. So then that way, everyone can kind of reference this going forward and everything like that. So how's that sound, Tobias?
Sounds awesome.
Wonderful.
Yes.
Well, yeah, so we can start getting into a couple of things here. So first things first, I do just want to mention that you can support this show over on Patreon at patreon.com/turbomakesgames, or just go to hotpathshow.com. And over there, we have a bunch of fun bonuses if you do want to support the show. Of course, everything on this show is going to be available to everybody, but there are some additional fun bonuses if you do want to support us there. I did post my talk for modular data-oriented design up there, which I think was a really good and interesting talk. And also, I just put up a poll for the next bonus episode, so I can actually kind of share what the different options are here. This poll is up right now to all Patreon supporters. So for the bonus episode, a couple ideas that I was kicking around would be how I would make a Roller Coaster Tycoon 2 with dots, how I got started in contract game dev, how I get things done, and using dots for non-game applications. So feel free to if you want to vote on this month's topic, feel free to head over to the Patreon for that stuff. And then also we're going to be posting some behind the scenes episodes and stuff like that in the coming weeks here. Another thing that I do just want to mention real quick is that we also do have a clips channel for the Hot Path Show now. So I can go ahead and I have a link here that I can go ahead and drop in the chat, but it's just over at Hot Path Show is what the YouTube handle for that is. And you can follow that, and we'll be breaking out some of the smaller sections into different clips so you can kind of rewatch some of the different highlights of the shows and everything like that. So here's another fun thing that I wanted to bring up before we kind of get into the main show is I just finished filming the kind of like main tutorial section of my big Netcode for Entities course tutorial that I've been working on, and it's going to be posted just on the Turbo Makes Games YouTube channel. So I wanted to do a fun little guessing game here, and we can have Tobias playing along because he doesn't know the answer to this. And of course, everyone in the chat can play along. So just wanted to ask, how long of raw footage do you think I've recorded so far for just the tutorial portion of this video? I still have to do just some things like the intro and things like that. But so far I have the full, tutorial section actually recorded. So I want everyone to go ahead and put some guesses in the chat, and Tobias, feel free to guess as well how long you think that is.
Now, you want to?
Yeah, go for it.
Yeah. 5 hours? I have no idea.
Good guess. Good guess. Let's see if anybody else in the chat has 30 hours. 2 hours after edit. I don't know how much it's going to be after the edit, but I definitely am going to be cutting down quite a bit from where it's at right now. I've already gone through a little bit and cut out a decent chunk of time. So far we have some over, some under. Give everybody a couple more chances to guess here. Tobias, you wanna submit another guess?
I am pretty comfortable with my 5 hours.
Okay.
Yeah. I don't know. I've never done anything like that myself, so but I don't know. I think
12
that
and 25 are getting a little bit closer.
oh, okay. So I guess too little. Yeah, yeah. But I made my choice. It's cheating if I get to crowdsource it.
Fair, fair. We'll let one more guess come through, and then I'll reveal the answer here. Well, if no one else has any other guesses, then I suppose Wayne Games probably closest. 12 hours before edit, he had it just right in before Continental Code. It looks like, but so it's about 16 hours and 45 minutes.
Okay, so I was 3 times
Yeah.
off.
Yeah. So that is it is I am going to be cutting out a lot of that. Like some of the stuff is like from, the project compiling and building and everything like that. And there were a couple times where like I just had the camera running where I like stepped away for a little bit. So I've already cut out like probably 3 hours of from that final time. So yeah, it's definitely going to be a very long tutorial, and I'm pretty happy with it so far. So yeah, very much looking forward to that going out. Again, I'm going to be doing a big netcode for entities tutorial and creating like a MOBA style game for that. So anyways, we can get into some of our main segments here, and we're going to start with the prefetch, which is just kind of like our warm-up topic for the day. Wanted to bring this up. Actually, Tobias, I forgot to do something here, and this kind of leads into some stuff that I had for the prefetch anyways. So real quick, I know we've had you on the channel before a couple of times, and we kind of went into more of like a deep dive into your background and everything and what you're doing right now. So if you could actually just real quickly just give a quick introduction into yourself, some of the things that you've done, and some of the things that you're doing right now.
Yeah, so Tobias, as you introduced me, I live in Sweden. I've been developing games professionally for 11 years soon, I think. And I started my career at Stunlock Studios, which made working on a game called Battle Right, and worked there for 6.5 years, mostly on system tools and stuff like that, and also a lot of camera production stuff, which I love video editing
Right, right.
with the tooling with that, animating cameras with VR, but that's a story for another day. And then 2019, I decided that I didn't want to do top down anymore, and Stunlock only does top down so far. So I started my own company, Bang, where I'm currently working on Just Read the Instructions, which is a 4-player co-op first-person shooter. We're using dots, 4,000 enemies at the same time, fully custom network stack, and a lot of fancy cool stuff that I am proud of. But that's very much in the dots area, dots or GPU areas domain. So yeah, been working on that for 4.5 years now. Probably going to be released pretty soon. So excited for that.
Yeah, yeah. No,
Yeah.
I'm very much looking forward to the release of that as well. By the way, I do have the Steam page in the description of this video
Oh
here, so
yeah,
you can
look
go
at
ahead
that.
and wish list
Yeah.
that.
And also I've been consulting a bunch in between. So I worked on I've worked on Raft, and we'll get into another game that I worked on actually later, I
Yeah,
guess.
yeah, yeah,
Yeah, yeah,
yeah.
yeah. But so yeah, I optimized the collision in Raft so you can build super big super big rafts, I guess, without your performance tanking. So yeah, but a little bit here and there, and then now I'm full steam ahead on my game. Yeah.
Nice. Awesome. Yeah. No, yeah. And your game, I think, is really cool. We've talked about some of the tech that you have built into it, and there's definitely a lot of really cool and interesting stuff there, and some cool ways that you've used dots. And so, yeah, very much looking forward to, getting into some of the things that you've built out over the, weeks to come of the Hot Path show.
Yeah.
So yeah, anyways, the kind of prefetch topic of the week here is going to be the PlayStation State of Play that just happened the other day. Kind kind of myself being involved in the games industry, I always like watching the different showcases for all the, big companies like, Sony, Microsoft, Nintendo, everybody like that. And so Sony just had one the other day. They call it the State of Play. And wanted to bring this up because there's actually a couple interesting games here that are kind of tangentially related to Tobias. So as we talk about some of these things here, I can have them play. So actually, the first game that was showed off in the State of Play was Helldivers 2. The reason that I wanted to bring this up is because Tobias actually worked on, was it the expansion of the original Helldivers game?
Yes, it was an expansion, very late expansion actually. Helldivers is a pretty old game. I think it's launched like 2014 or something like that.
Right. Yeah.
Yeah, so I worked on the expansion called Dive Harder. That was my first thing straight out of after Stanlock Studios. Coming from Stanlock Studios with Unity, and then or a lot of custom in-house stuff, but Unity primarily, and then going into BitSquid with Helldivers. That was a whiplash, I can tell you.
Yeah.
Yeah, I can just point one thing out that is kind of funny to me, because I've been in this discussion about a few times with people online who, we all have complaints about Unity and things that we want them to make or not make.
Right.
And if you worked in like a more smaller engine like BitSquid, and you're used to the tooling and the editor and the smoothness of the editor in Unity, you go into BitSquid and you're like, oh, okay, I should be pretty all right with some of the stuff in Unity. This is, well, I don't want to put them down, but it's sort of horrible in the comparison in some of the ways. So yeah. So
yeah,
Unity
I don't even know
has.
if I had heard of BitSquid bbefore I was talking to you about it the other day.
Yeah, it's. I think it's actually written by a Swedish team a long time ago.
Okay.
And it uses Lua as the scripting language, which is pretty nice since it's hot reloaded and stuff like that. But it's like it's a completely different experience than Unity. It's way scattered, and stuff is not at all as easy to work with as in Unity. There's not a lot. There's not even like a scene editor like that you have in BitSquid.
Okay,
It's
interesting.
Yeah, so
is there any like one feature that BitSquid has that you wish was in Unity or other common game engines?
well, the hot reloaded Lua thing was pretty nice.
Sure, yeah.
Yeah, but and I don't really know if this is the best way, but in if you crash in Unity, you have the whole goddamn thing crash, right? BitSquid is made up of several executables, and every executable does. Imagine sort of the rough different views you have in Unity, and then
So maybe you could have like maybe like the profiler could crash, but it doesn't affect your game kind
yeah,
of thing.
yeah, or like like you have a specific inspect the model thing in BitSquid that it's separate executable, and Unity could maybe approach that sometime, but it's also very annoying to have like 10 different executable running to be able to
Yeah,
do
sure.
everything you're supposed to. So it's a little bit, but if anything crashed, nothing else crashed in BitSquid, which was pretty nice. So yeah. So
Fair
that's
enough. Makes
I'm not
sense.
sure, but it's a cool idea at least. It's like Chrome, with every tab being a separate executable.
I get you.
It's
I get
very
you.
similar. Yeah.
Yeah. Well, yeah, anyways, Helldivers 2 is actually coming out in just a couple of days. It is a different kind of style, whereas the previous one, that one was more like a top-down, whereas this is a third-person style one. I don't know what engine they're using. You think they're probably not using BitSquid anymore?
No, they're not using BitSquid. The Arrowhead who developed it, they are like, yeah, we are moving on from this. Yeah, I think it was more or less because they were probably pretty close to the people who originally developed BitSquid.
Gotcha.
And
Gotcha.
we shouldn't settle for Unity Unreal forever. We should try to make new fun stuff also sometimes. So
Yeah,
I
totally.
support their experiment.
Yeah.
Yeah.
All right. So, anyways, the next thing that I wanted to bring up from the PlayStation State of Play, we have a Stunlock Studios logo here. So, wanted to bring this up because V Rising is coming to PS5. As many of you know, V Rising is a game made with Unity's Entity Component system. Unity actually did a live stream with a couple of the developers who you are good friends with, Tobias, and they talked a lot about how they used ECS and like all the interesting ways for gameplay as well as editor tooling. There's a lot of really cool stuff that they did, and just like kind of talked about why their game kind of like needed ECS to basically make the goal that they had in mind. But yeah, I wanted to bring this up because I thought it was funny that there was a couple things inside the PlayStation State of Play that were again kind of in your orbit because you previously worked at Stunlock Studios, and here it is getting featured, and we got V Rising coming to PS5.
Yeah, yeah. There's a lot of stuff, and sometimes I feel like, why did I jump ship just as they presented this like 2-3 months before I said bye, and that was because it was not a top down game, and didn't want to do another top down game. So that's the basic reason why I.
Interesting,
Yeah,
interesting.
that's it. It's but it was slightly different at that time, but the main concept was actually
How
pretty.
much did you know about the tech that they were
Oh,
like
most of
going to
it.
use? I mean, at the time when you were like considering leaving and everything like that, did you know that they were going to use some type of data oriented design, or did they have any of that kind of in mind and figured out at that time yet?
Well, so it's a little bit chicken and egg situation because because when they announced it, I don't think dots was really on the minds of most people. No, this was 2000 early spring 2019, so
Okay,
dots
yeah,
was barely presented. Yeah, I
right.
think they presented Burst and the idea of ECS 2018, if I'm not misremembering. And but like they showed this, and but it wasn't supposed to be this big, I think, in the beginning.
Hmm.
I might be wrong on that, but and then me and Rasmus, one of the people who was on stream, Rasmus showed me dots, and then we started experimenting with it. And that by that time, I've already sort of decided to leave. I didn't realize this was going to be this big of a project using the data oriented stack and everything like that.
Right.
So before I left, I understood where they were going with it, the whole shebang. But I already decided, and you know, I'm not a fantasy fan, so for me, it wasn't like I wasn't very convinced either way. I'm like, maybe it works, I don't know. But now we know they made a very nice game, super successful. So I'm super happy for them.
Yeah,
But at
yeah,
that time, I
absolutely.
had a completely different view of it.
Right. Yeah. It's one of those things. It's like when they're pitching the game, you see like, oh, kind of a top down hack and slash game. You're like, oh, I don't know if I'm super interested in that kind of thing.
Yeah,
But then, yeah, again, as I'm sure as the game kind of grew and evolved, and they were able to lean on a lot more of the cool tech, and of course, it turned out to be a very successful game. Probably Stunlock Studios' most successful game.
yeah,
Is
by
that fair to
far,
say?
by far.
Yeah.
Battle Right was a successful game,
Yeah.
but it
Yeah. Very
wasn't like.
popular. Yeah.
Yeah, but this is a complete blowout. If I understand it correctly, I think they sold more than 3 million copies, which, if you do the math, is a lot of
Yeah.
money.
By
Yeah.
the way, I do gotta put you on the spot a little bit for Battle Right because you, you know what I'm gonna say, right? When you had that interview at E3.
Oh yeah. Oh my God. Yes, I
Yeah,
presented
yeah.
Battle
So
Right for
Tobias, yeah,
PlayStation.
he presented yeah, Battle Right, and on the E3 show floors because you had kind of like made a trailer for Battle Right, and then they
Yeah.
basically just sent you for that, right?
Well, I asked if I wasn't when I asked my boss, I knew that our PR manager wasn't too much into the interview, which is kind of ironic. He's really good at
That's
the
funny.
PR work all over, but he doesn't want to be the
He doesn't
front
want to be
person.
the yeah.
Yeah, yeah. So I asked, like, if nobody want to go, maybe I could go. And my my boss was like, yeah, all right, you're going. What? Have a good one. And I was like,
Yeah, so
what?
there's an interview on YouTube where because it was like the Microsoft stage that you're on, right?
Not the Microsoft. They didn't Microsoft Daily Show. It was supposed to
Yeah,
be
okay,
the
yeah, the
big
Daily
stage from
Show.
the beginning, but it turned out that they wanted only the Daily Show. But it's, yeah, still shit nervous.
Yeah, yeah, totally.
Uh, but I might just two fascinating small snippets from because I talked to my old colleagues a lot about this game during their development. Two fascinating small things that they told me, like this game is not possible what with the old architecture in Unity. It's just
Hmm.
not a thing. And one of the things that really it makes it easier in dots is they have way better processing of like snapshot changes and like all the states, so you can understand like what every player knows, because you know you can cut down any tree or anything like that, and you need to manage to know who needs information about what cut down tree or what enemy killed or what projectile is flying, and that sort of all that code and all that data that needs to be processed, and make sure you're not trying to sync a megabyte every frame. That thing, if I understand correctly, and might be wrong, but what I've talked about a lot with Rasmus about it, he's like that is one of the things that they can do a lot faster using dots, because it's so much things that they need to keep track of in a full world.
Yeah, totally.
Yeah. And so that's a dots thing. It really comes in handy. And then another funny thing, I think, and this is like for me working on my own game and having like understanding the technical problems around dots, and not like limitations, I should say, where you should not do anything. There's things you shouldn't do in dots, right? And then realizing what happens when you put designers into, because there's a lot of designers at Stunlock who code themselves.
Oh, okay, nice.
And one of the things is that I think they had like some sort of AI component that was growing and growing for a boss. And in the end, I think they exceeded the size of a chunk for one single entity. That blew my mind. So you have one entity with a few components, and a few of them are like huge because they're so complex enemy states.
Right.
And because of how it's spaced, it's like, it's more than we can't handle this in one chunk. I might be wrong, but it was something along like
funny.
It was just too big of a component. And in my game, it's like inconceivable to have that big of a component. So I was like, what? Okay, all right, that's funny.
That is funny.
Yeah.
So that's kind of the other main thing that I wanted to bring up. Also, real quick, got to give a quick shout out, Death Stranding 2. Did you ever play the first Death Stranding game?
No, that it's only on PlayStation, right?
They brought it to PC now.
Okay. Maybe I should give it a try someday. But I never owned a PlayStation actually. So
okay.
Yeah, I played a bunch of games randomly but never owned my own. So
the original Death Stranding game was just so interesting to me. Like, it's very unique in terms of gameplay. Like, it's basically like a hiking simulator, and it's just super interesting about, you have to kind of like manage all your gear and like, figure out how to kind of like use all those tools to, you're almost like treating the like world terrain as like a boss, and you got to like kind of like figure out this like whole puzzle thing. Very interesting, and just the story and everything is so weird. Like, I'll just kind of play this a little bit here so you can just get a quick little glimpse into like Kojima's mind. So you can see these like like glove things around this person's head that like snap and light a cigarette, and it's just like cool stuff like this. Like, it's just like, how does he even come up with all this? So super interesting stuff.
I've
so
seen a bunch
for the
of
next
it.
one.
I've seen the Donkey review, I think, when he makes fun of it, and I've seen people being fascinated by it. So it's a fascinating game.
Donkey, he did not seem fond of that game. And I love how that's kind of like a recurring theme in like all his videos. Like, going forward, he's like, "Oh, this is a Strand type game."
Pretty funny. Yeah.
So anyways, that was kind of the prefetch, our little warm-up topic as we get into things here. Next part of the show is the error correction code, where we do our corrections from the previous episode. Luckily, it didn't seem like there were any kind of major corrections or mistakes that we had from the previous episode. So, still batting 1,000 over here. But anyways, I do just want to bring this up because, if there is anything that we get incorrect, or maybe you want to provide some additional context for some things that you think people would find helpful, feel free to leave that in the comment section of this video, and we'll bring it up on the next episode. Anyways, we'll go into our cache hit, our Unity Dots quick tip of the week. So Tobias, you have the quick tip here, so feel free to share your screen, and we'll hope that things don't crash.
I for the viewers, I've had every time I tried it, basically, unless I just restarted, it just instantly crashes all my windows, my browser windows. So let's
Yeah.
see what happens.
Oh no, he froze. Oh no. All right, looks like he's probably going to end up having to restart here.
Jesus Christ! I think
Didn't work.
I don't know. I think I should send the code to you, and you can put it up on. I send it to Discord, and you can
Yeah, okay. We
uh,
could do that way.
just I can just guide you. Let's not fuss around my. I don't know
Yeah,
what it is. It's very strange. I
fair
just
enough. I have a writer open here, so let me just make like a new file.
it should compile if you have entities, so you can just put it anywhere.
Yeah.
Fascinating. Insta crash.
Yeah, that's hilarious. Okay, so I will do this and
All right.
okay.
I'm gonna put full screen here so I can see, and you can scroll down to the on update thing, and I can just explain what's going on here. So this is obviously a conceived example, but so on the line 40 here, we have a situation where maybe you have a boss, and the boss has a few targets. Maybe it's like minions or projectiles that the player is sending out, and we need to go into the for each loop on line 46, and in the player logic we need to like work with the boss targets. So you have like a situation where two entities data is involved in the same situation, sort of. So you can see there I'm doing something on like line 56. I'm reading the target 0 and just putting it somewhere. Imagine something happening where the player needs to understand what the boss is targeting or something. If I do this, because I pick out a dynamic buffer, which is an array that you can associate with an entity. For those who doesn't know, so you can have I guess we shouldn't go that much into basics, but if you pick out this array on line 40, and you have like read only or write true or false, it doesn't matter. If you pick out, and then because you're jumping into something doing anything that Unity considers or ECS considered might change the structure of things. So that means that when you're trying to access it on line 56, you will get you cannot access this because it's been invalidated by possible structural changes. The thing is that you don't really care if it's structural change or not, because your target list will not have changed either way. You just want to know the target list.
Right.
But Unity has, they have requirements on their memory safety. So this and this is not strictly exactly all the time you get errors like this, but generally speaking, if you pick up a dynamic buffer and you're trying to use it just like it is, along with working with other entities or other like adding, removing, or just modifying components, you will get like, no, you cannot do this because we might have changed something in the background. So the trick to do this is if you uncomment 40 and then comment take back 42. So now you can see we do two native array with temp allocator. And the allocator could you be using different one depending on what you're using with it, but you just the easiest way to solve this is to use that extension, because that makes a copy of that array and put it, so you don't actually access the source data in the dynamic buffer anymore. You just access your local copy of it, and that is like zero backsides to it except for a slight copy, but it's super fast, and you can do whatever you want with that array after that. And it's just whenever you're working with dynamic buffers and you're not explicitly working with just that entity. So you might be doing, you should, like in my case, in my experience, you should not almost always just make a copy of it into a normal native array that is just standalone, and just work with that instead of the dynamic buffer original source data, because Unity will be very annoyed at you anytime you touch anything. Like, no, you need to put, you can't touch this again.
Right, right.
Yeah. So yeah, it cleans up some type of code a lot if you just do a copy of it, and then you can put it back if you modify it. It's no problem. But
Yep.
then now you just have a copy. Yeah. And I guess we could maybe expand on it one further, because if we look at the boss targets component, you can just go, it's slightly further up. You have like a boss targets there. Yeah, you see it's just an entity. So in that case, and that's a pretty normal situation where you
Right.
just
You
have a
just
list
have,
of
you're just keeping
entities.
track of one thing. Yeah.
Exactly. So then if you go back down and you see, we look on line 52 and on 56. First one you have there, I'm doing something with a target. I'm setting some gameplay state on it, right? And then on 56, I'm doing the thing we talked about earlier. I'm reading from it again. And I think both of these will make exception if you, depending on situations. But we need to do the point entity thing all the time. And that's not a big deal, but it can be simplified slightly, because we only have a straight up one entity inside of the buffer element. So if you the comment 42 and then uncomment 44, then we and this, both the reinterpret and toNative array can be switched around. I don't think it matters which way, but the reinterpret, which is an overloading, which is something that's you get the same array back. They don't do anything. They don't do a copy or anything. It's just like, okay, we got this memory, but if we just view it through a different type scope and like, oh, this isn't boss targets anymore. It's just straight up an entity. And if boss targets only contains entities straight up, it's the same memory. It doesn't matter. It's just exactly the same layout. So now if you see you have an error now on 46, and that's because entity, you can just remove the entities on both 52 and 56. So if you remove that now and that one other, because targets now, if you hold over it, targets is just a straight up
Native array of entity.
Yeah.
Yeah.
And but you need to be careful, so you know that you reinterpret the array into the same thing, sort of fundamentally. But this way, and I use this reinterpret entity all the time in my game, because it's just easier to know that this is just straight up an entity array. And then you can reinterpret it back into boss targets and put it back into if you modify it. So reinterpret is very, very handy to make that kind of code much cleaner.
So do you use reinterpret on the native array, and then that's how you can get the a dynamic buffer back? Is that what you mean?
Yeah. I just do, if you try after the run here and just put targets dot reinterpret boss targets, and then you can put that straight into anything.
Nice.
So that's just a straight native array with boss targets in, and it's the same thing. It's the identical memory.
Awesome. That's great.
Yeah. So yeah, that was my quick tip. I had like a year of dots programming before I realized the first one, and working with dynamic buffers is so annoying unless you work with the copy of it all the time.
Yeah. They're handy, and but yeah, I think these are definitely helpful things to use. Admittedly, the reinterpret one, I had used this like a long time ago, but I haven't really been using it too much recently. So now that you remind me of it, I'll have to probably. I'm already thinking of a couple places that I can use this for some things. So
yeah, and it's not that much you can do with it except for this one. But this one is really helpful.
Yeah, absolutely. Sweet. So yeah, that is our Unity Dots quick tip of the week. So now we can go ahead and we'll do our context switch. So here we're just going to go ahead and Actually wanted to bring up a little bit of a forum post here today, because here's normally where we would do sharing like the dots changelog or something along those lines. However, no new dots changelog right now. But I want to go ahead and actually share this forum post from a little icon that some of you may recognize, Hugo, Code Monkey. He actually had sent me over this kind of issue that he had brought up, or that he had kind of discovered as he was kind of diving back into dots. And I think this forum post does a really good job about just like highlighting a couple misconceptions that people may have, especially as they're starting to get into dots. And then further down the forum thread, there's actually a couple other really interesting topics that get a little bit more advanced on a couple of things here. So anyways, the root of the issue, basically what Hugo was noticing, is that he's using an iJob entity with a .schedule parallel. And he's saying, as far as I know, this should split the job to run on multiple threads, but it's not doing that. It's only running on a single thread. So you can see here what he has is just this simple rotating cube job. And it's going to go ahead and rotate everything with these proper components and everything like that. And then he also had just kind of some like extra logic in here just to like make this whole section of code just be more efficient than necessary. So it would be a little inefficient than necessary. So it would be more obvious in the profiler here on some things. And it's funny because later on he actually enabled burst, and burst basically just removed all of this code here. So so basically all it was doing is just the actual rotation part, whereas doing something and not just doing some calculation that doesn't really do anything. Going through, here's kind of a look at his profiler, and you can see that he has a bunch of idle worker threads, and he has this rotating cube job just kind of going here. So the reason that he was experiencing this is because he was only testing this against, I think, about 200 entities. Now, what's ended up happening is because 200 entities, that's probably going to fit into two chunks, because one chunk is a pre-allocated block of memory, which is 16 kilobytes in size, and that's where all like the entity data is stored. Now, chunks can have a maximum of 128 entities. So, just having a couple lightweight entities, these were probably separated across two chunks. And the reason I'm bringing up these chunks is because when you do this iJob entity and it, updates the local transform on all these entities, each worker thread is running on a per chunk basis rather than a per entity basis. And that has kind of a lot to do with like just how the memory efficiency works of Unity ECS, because if everything is in one chunk of memory and then you have one worker thread kind of pull that chunk of memory into the cache and everything like that, then it can just easily iterate through all those entities in that one particular chunk. So it actually is kind of an efficiency gain, even though we're not rotating everything across all the different worker threads. We're just kind of operating on one chunk of memory at a time. So it's really kind of about managing memory in that case. So they kind of brought it up. So talk about 200 entities, 128 entities per chunk. I did kind of highlight this here as a little teaser on some things that we're going to see later on when we talk a little bit more in depth about the transform system here. But then he said, yep, that does appear to be correct. When he increased this to 1,000 entities, then now we start seeing the rotate cube job go across multiple worker threads and everything like that. So again, that's kind of the main solution there, the main reason that he was seeing that. But then going on, this goes into a little bit more of the kind of deeper related topics. And so someone says, what can I do if I've got some long-running operations on a few entities inside one chunk and I want it to be performed on multiple worker threads? So there did actually used to be this iJob entity batch, and there was a schedule granularity option where you could actually run jobs on a per entity or a per chunk basis. You could you could kind of differentiate between the two. That is no longer a feature, and we can maybe again, I think kind of the main reason is because with the iJob entities and everything like that, like I was mentioning with the memory efficiency, we prefer to be operating on one chunk at a time. But there are ways, other ways that we can do it on a per entity basis if we want to. I wanted to bring this up before moving on because I just wanted to ask you, Tobias, had you ever used like any of the schedule granularity stuff for any jobs that you had been working on where, maybe you wanted things to be parallelized on a per entity basis?
No, I didn't actually know until this forum pointed that out. But I can say that I've sort of hacked around it by disabling a bunch of the safety features and then just scheduling one job manually at a time for every entity. So there is ways to get around it, but with still having the safety system fully engaged, I think this is probably the best way.
Right, right. And yeah, so I did want to mention here. So Turtle says that you can create a list of entities using to entity list async and then pass them into an iJob parallel for defer and set the inner loop batch count to 1 if you want one entity per worker. So there is kind of, some ways that you can get around that where you would create more of like a manual job as opposed to the iJob entity where it does kind of some code generation stuff for you. It's just not possible with how the current setup is used to do a one entity per worker thread scheduling. But again, you can use just kind of like some of the things built off of regular jobs to actually get that granularity if you need it.
All right.
Yeah, and then so I also kind of wanted to bring up the concept of longer running jobs because when you kind of like initially think of like hear of like what the job system is and everything like that, like you're able to kind of like parallelize work and all that. One of the things that your mind kind of maybe goes to is like maybe having longer running jobs where you have some like really complex calculation that could take potentially, maybe even a couple seconds longer than a couple frames. And you start thinking like, oh, maybe that's kind of like a way that I could kind of use the job system. Although that's not necessarily the best, thing to do for many reasons that we could get into, but kind of wanted to bring this up. Like, Tobias, have you kind of considered using longer running jobs or looked at some alternatives for some things like that?
Yeah, I have a longer job in running jobs in my game, but it's in a different context. It's not when the game is 60 FPS. It's when I generate my world. I have a few jobs that are kind of slow, and the runs maybe for I don't know 300-400 milliseconds, something like that. But that's a different situation. I never, yeah, that situation of like letting it run through several frames in the background.
Right.
I don't think I have anything like that.
Yeah, yeah. And I kind of just want to bring up like maybe some of the issues with that are, especially when you're working with entity data and you say schedule a job that, could run, many frames long, there could be a difference between the entities that it was scheduled on at the beginning of that job and the end of that job. So, maybe if you're saying run this job on these entities, well, that runs across 10 frames. Well, that entity might have gotten destroyed by the end of that. And so that could kind of lead to some weird issues. And then also, if you're working with entity data, one of the things that Turtle brings up here as well is that you'd probably have to do some double buffering on your data. So essentially you have kind of like the live data that like all your other systems are kind of like dealing with and interacting with. But then you also have like a copy of that data component. So you have like another data component that kind of longer running job is kind of like modifying in real time. So it doesn't like affect all the other systems. And then, once that's complete, then you could kind of, push that data to your main live data, if that makes sense.
Yeah, I was going to say that I think most of the situation where this would be reasonable is when the data you're working with is not really well, it is connected to the ECS world, but it's still like more or less like, yeah, you just have an isolated piece of data and you put it in some buffers or some arrays or whatever, and you like go on maybe like pathfinding or something. You don't really
Right.
need to know
Yeah. Yeah.
much about the world currently, because pathfinding is something that could be take half a second and nobody would care.
Right.
Yeah,
Yeah.
yeah,
And again, yeah, you're not just limited to using jobs. You of course can use like, asynchronous methods to do things like this, where it, still would kind of end up getting pushed off to a different thread. But again, maybe you're not working directly with that entity data, so you wouldn't have some of those similar problems. You still kind of would have to do probably some sort of essentially double buffering thing where you're, copying some data over, running a long asynchronous work on that, and then bringing it back over into the entity side at some point.
yeah.
So yeah, anyways, that's kind of what I have for the context switch here today as we kind of move into some of the more ECS related topics. And then so now we can get into instruction set. And today we're going to be doing a deep dive into the Unity ECS transform system. Again, I wanted to bring this up kind of early on in our show run because I do think that it is a very fundamental concept of ECS and data-oriented design. There's a lot of really interesting things actually in the transform system as you kind of dive deeper and you kind of start to see why they made some of the decisions that they did for some particular things. So anyways, I'm actually going to start over in the Unity documentation for this. Reason is because I think the Unity documentation actually has a lot of really good information on the transform system. And so I don't want to spend a ton of time here just because, this stuff is all, of course, available to everybody. They can read through on their own. But I do just want to kind of bring some things up just so we kind of have like a good baseline before we start getting into some things here. So if you look over in the documentation, there's kind of the transform concepts here. So this is just kind of like a quick introduction into the main different transform components. Now, the Unity ECS transform system has kind of gone through multiple evolutions, since it's came out. And at one point they had, like separate components for like transform and rotation and scale and everything like that. So I think it's at a pretty decent spot right now. Things are kind of consolidated a little bit, but there's still kind of like some differences that this has versus kind of Unity's regular transform system. So notably, the main difference is there's two kind of main components that basically kind of track, what the transform is. So their first one is kind of the one that you'll be interacting with the most part, which is the local transform component. If we take a look at this here, you'll see that what it has is fields for position, rotation, and scale. And so this is kind of, how you can, basically set, like it says, the position, rotation, and scale of an object. The reason that this is called the local transform is because this is the transform relative to its local space. So if this is just kind of like a root entity sitting in a subscene or something of that nature, then it's going to be local to that world. However, the Unity ECS transform system is a hierarchical system, so you can have kind of child entities and kind of have like a whole hierarchical parent structure, so that now this local transform would be local to the parent's position. So you have your parent's position, and then the local transform is essentially just the offset from that. So as you move the parent around, that child entity is going to stay at that same offset relative to the parent. So that would be like, if you had a car and you want, separate wheels that can kind of spin around on their own, and maybe they move up and down a little bit relative to the car as, the car goes over bumps and everything like that. So that's kind of how you would implement something like that. Again, that local transform would be basically the difference between, say, like the center of the wheel versus like the pivot of what your car is at. And then so, yeah, this uses just kind of like pretty easy to use components for the position, rotation, and scale. So they're kind of, easy enough to manipulate. However, the other one that we also have is the local to world. Now, every component that's going to be, or every entity that's going to be rendered is going to have this local to world component. And this local to world component basically is a float 4x4 matrix. So it's a total of 16 floats inside this local to world here. The purpose of the local to world is to give the transform, or the position, rotation, and scale in world space. So no matter where this entity sits in the hierarchy of parent structures and everything of that nature, this local to world is always going to basically give the exact, world relative translation, rotation, and scale. So we kind of have these two separate components here where we kind of differentiate between a local transform relative to any parents as well as the local to world. Now, this local to world is computed in a special local to world system where it takes the transform and then converts that over to a 4x4 matrix. And then from there, it will also, keep track of, any parent positions or anything of that nature and apply those translations. Now, it's really cool because this local to world component, again, this is a float 4x4 matrix. And so if you actually look into the source code, which I can go ahead and bring up here for the local to world system, I'll have to switch my screen here. So this here is the local to world system, and you can see that there are different jobs in here for the compute root local to world job. So basically what is happening here is we can kind of look into, where am I exactly? Yeah, so we see that there's let me think about what the best part to show would be. So yeah, we can see here that when we're actually setting the, this is essentially, we can consider this the local to world for the current entity that we're going to be iterating against, because this is kind of happening in a little bit of a loop here because we're looping through all the entities in a particular chunk. So actually, I should probably showcase this because this is kind of the basic thing here. So all it really is doing is it's just taking the transform and just doing a .to matrix on it. And then it goes ahead and just sets that in the local to world. So this would be like, if this is just kind of like a regular entity, it doesn't have a parent or it doesn't have any kind of crazy scaling or anything going on. All it does is just converts this local transform to a matrix. And kind of diving into this, you'll see basically what it's doing here is we take in the translation, rotation, and scale. We first make a float 3x3 matrix with the rotation. And this kind of looks to be like the most kind of, intensive part here when I was kind of going through some of this source code here. So you see that it's just kind of doing a lot of, multiplication. There's some exponential stuff going on here. So it kind of takes that quaternion and converts it to a float 3x3 matrix. And then kind of using those values from that rotation matrix, we can create our float 4x4 matrix by kind of doing some multiplications with the scale. And then you'll see at the end, we're also just passing in the translation. So there is just kind of like it's mostly basic math operations, what we're doing here. Again, just kind of creating that 4x4 matrix. Now, kind of one of the reasons that this is actually stored in a matrix, and again, I didn't write the ECS source code, of course, so this is kind of me going out on a limb and guessing on some things. But there are a lot of cool things that we can do with the 4x4 matrix that make things really easy. So for example, when we go into this compute child local to world job, this is what we would be doing if, say, we have a parent game object, or we have a like a hierarchical thing where we need to take the local position, and then the like parents world position, and then and then actually calculate the world position for the child. So
I just to clarify what you said there, I can point
yeah,
out
yeah,
that
please.
like normally if you would do it very manually, very naively, maybe you could call it putting position, rotation, and scale, and like putting them on top of each other. That would be like a lot of manual work to make all of them work together to make like a child of a child of a child and calculate all of that. But
Right.
with a 4x4 matrix, you can just add transformations on top of each other, just multiply the next local to world onto the next, and you just going click down in the hierarchy forever. And it's just like 4x4 matrix multiplication in itself is kind of a complicated thing, but like conceptually you just put on matrices on, stack them on top of each other, and you will just get the end child transform perfectly fine, and you don't have to
Yeah.
do a bunch of intricate work with the position and rotation,
Yeah.
etc.
So yeah,
Yeah,
yeah, you could either do it, yeah, very manually, like you were saying, where you're like actually saying, take the position and then add the position, but oh wait, there's also a rotation on the
yeah,
parent
yeah,
object. So now we need to, we can't just rotate the child. We actually have to like, rotate it around the parent's position and everything like that. Whereas if we have this in a matrix, then all we need to do here is literally just this one line of code where we take the parent's local to world and then do the vector multiple, or the matrix multiplication with the local transform.to matrix of the child.
and you get the yeah.
And then if you go into the actual 4x4 matrix multiplication, you see that all it is just a lot of multiplication and addition. And the nice thing about this is with the burst compiler, this can easily be vectorized. So a lot of this can be combined into just single instruction calls. So it is pretty efficient for the burst compiler to do all this stuff here.
And just to like, this is very unique to dots, really. It's just very nice to be able to see the source code straight up like this, written in a very
Oh, I
easy to
agree.
understand
Yeah.
C# language. But like traditional Unity uses the same thing. It's just hidden in C++ code in the, it's I think local to world matrix or something it's called. So this is even like, I think the old DirectX 3D that I worked with first time in 2008. This was the standard way of doing it. So this is a very the preferred way, and
Yeah,
this is
yeah,
just
yeah.
very nice to have it
Very, yeah, rock
explicit like
solid.
this.
Yeah. Yeah. So, anyways, that's kind of a little bit of the basics on kind of why there is a difference between having a local transform and a local to world component, and then that local to world component. Again, this is basically what gets actually sent over to the GPU, along with the mesh data and everything like that, so the computer knows actually where to render the entity on screen. So I think there were still a couple other. Did you have something to say?
Yeah, just point out a very I maybe you already pro, a very good thing about the local to world thing, instead of the matrix when you're working, is you have three floats for the position, one for the scale, so you only scale uniformly in that particular case, and then four for the quaternion. So that means you have eight floats for every local to world instead of 16. So you just half as much memory until you get to the point where you need to figure out the whole hierarchy. So I would assume that's they could just use a 4x4 matrix everywhere, and then have like access function and simplification functions to be able to change position and scale and everything. And I think that's what's transform in Unity, the standard Unity basically does behind the scenes,
Okay.
or something. Maybe not exactly like that, but you certainly save a lot of space by having like, you don't actually have it you don't work with it 4x4 until you get to the
Right.
point where it
Yeah.
actually got
Yeah.
it. work, and it's just easier. There's
yeah,
no
you have,
real reason to have the 4x4 all the time.
Yeah, you have
Yeah.
8 floats instead of 16. So that actually kind of leads into the next thing that I wanted to talk about, whereas you may have noticed that on the local transform, this scale is just a float scaler. So it doesn't actually do like a non-uniform scale. So you can't scale it separately in the X, Y, and Z axes. You can just scale it uniformly. So it basically just kind of expands and shrinks at the same scale. However, there is a way that you can implement a non-uniform scale, and then what ends up getting added in that case is this post-transform matrix. Now you'll see that this post-transform matrix, if we go to the actual value of this is also type float 4x4. So now if you start using non-uniform scale, then now you have a whole nother float 4x4 matrix on there. And actually, one thing that I can go ahead and do is if we pull up the calculator, we can do a little bit of just quick math here. So again, a chunk is 16 kilobytes, so we can do 16 times 1024 is how many bytes are in a chunk. Now, the maximum entity count in a chunk is going to be 128, so we can divide that by 128, and we get 128. So basically what this means is that anything under 128 bytes, that means that we'll be able to fill the maximum entity count in a particular chunk. And then anything over 128 bytes, that means that our maximum potential entity count is going to start decreasing. So if we say minus 64 bytes for our local to world, and then we minus 32 bytes for our transform, that means that we pretty much only have 32 extra bytes to work with just by default. And then, so if we also add in a post-transform matrix, now you can see that we're kind of, already just with those components, before we even add anything on our own, we're already, under our kind of max potential entity count per chunk. So it does add quite a bit of memory when we start doing things like the non-uniform scale. So that's why it's probably best to avoid using any type of non-uniform scale, and just kind of, prefer to have everything set in your, asset creation stage, have all the scaling and everything set properly, so that when you bring it over to Unity, you can, ideally have just a uniform scale of a value of 1. But if you do have to just uniformly scale up or down, then that's going to save you a lot of bytes on memory there.
And the post thing, maybe, I don't know if you're going to bring that up straight off this, but there is a slight edge case which is not supported by this setup. Imagine you're having a root object, and you have two different entities on either side, and you sort of want to scale them in just one direction so they go far away from each other because of the scale of their parents. That's not possible because the post in post-transform matrix means it's after everything on the child. So you figure out everything, and then you just add the scale on the actual object, so it's not part of the hierarchy anymore. Well, I mean, I'm 95% sure that's the case. Maybe some Dots is still developing, but I remember reading something about that when it changed. So the post in post transform scales means that this only really applies because you might want to scale like the actual appearance of some end thing, and it doesn't really do anything with a hierarchy in itself. It's just like when you have figured out all the world transforms for everything, then you can individually scale things that you want to scale non-uniformly with this one, but it only applies to the child in itself.
Well, yeah, and actually you can kind of see in here in these jobs where it is actually kind of using this post-transform matrix, and basically if that chunk has the post-transform matrix, then it's just going to go ahead and factor this in. And you can see, again, it's just doing another, what's it called, matrix multiplication here on the local transform as well as the post-transform matrices. Yeah. The one thing that I do just want to call out on the post-transform matrix is you actually can use it for other things than non-uniform scale. So you can also do shear transforms or
Oh,
translating the entities relative to a pivot. So if you want to start doing a little bit more kind of, complex things with the transform where you're kind of like, projecting it onto a different, transform plane or something like that, like you can also use it for this. But, those are kind of not necessarily, the common use case.
yeah. So that's why it's like an optional thing and shouldn't be used unless you absolutely need it. I only use like 4 times in my game, and I have hundreds of different entities. So yeah, it's not commonly necessary for really anything.
Right, right.
Yeah.
And then, so yeah, just real quick, kind of going through some of the parenting stuff. So there is a particular parent component. The actual like underlying data is just an entity reference. So it's basically just kind of like a pointer to, whatever entity is the parent of this particular entity. And then also we have the child component, which is a dynamic buffer, which basically is just kind of, essentially a collection of all the children for a particular entity. And this kind of is important, and I'm going to be demonstrating something on this when we get to kind of a little bit of my sample project. But so
And
we can come back to that in a second.
just like
Yeah.
yeah, we can go to when you show. I can continue. It's better continue what you were doing. Yeah.
Fair enough. And then, yeah, so then there's kind of like a parenting system that kind of maintains this whole, parent-child relationship and everything like that. And so basically, the only thing that we really need to set when we get to the code is just, actually, and I'll show this when we get to it, so we can kind of come back to that. But yeah, and then just kind of going through the rest of this documentation here, I think is just super helpful, because if you go through here, it talks about kind of like using the API and like how to actually, manipulate things in the transform system. It is pretty, basic, easy to use stuff. There's this cool thing here for this transforms comparison, which actually is kind of like this essentially matrix where it has kind of the Unity engine properties and then the ECS equivalent over here. So if you're used to a lot of the Unity engine terminology, it's like, how do you do that on the ECS side? So you can see that there's all these kinds of things here, just all the basic things that we'd expect. They have some properties that don't have any equivalents. And there's also some methods. So if you want to, get children or do any, position and rotation or inverse transform point, things of that nature, it shows you how to do all this stuff here. So it's a lot of good, helpful resources as you start trying to do things that are, slightly a little bit more complicated, but definitely common things that you are going to be doing with transforms. And then transform helpers, these are just kind of some more extension methods and things of that nature. And the last thing that I wanted to point out, and we don't need to hit on this too long, is the transform usage flags. So when we're creating authoring components, we can define the transform usage flags for a particular entity. And this is how we essentially define what transform components are added to a given entity. So for example, if we say none, it means that this is basically a data-only entity, and it's not going to include any of those transform components that we were just talking about. For example, something like the renderer or renderable, it says indicates that an entity requires the necessary transform components to be rendered, but doesn't require the transform components to move the entity. So this basically just means it has just that local to world, but it doesn't have that transform component. So this would be good for something like a building that's just stationary in your world, and you don't need to move it. It can be a good way to just save on a couple extra bytes of data, if you don't need. And so that's just kind of like the basics of these transform usage flags. Is you can kind of specify the particular components that you need versus don't need. So one thing to point out is you may be wondering if you have, say, multiple of these authoring components, and say, one says, oh, the transform usage flags here are none, and the transform usage flags on this one are dynamic, and this one is renderable. What happens if you add those all to a given entity? Well, basically what it does is it just kind of like takes essentially the maximum of all of those. So it's like, whatever things that it's, adding from one authoring component, they're all just going to add, to that final entity. They're not going to like, negate out, or it's not going to go to like the lowest one. It basically just kind of cumulatively adds things up on there. So that is transform usage flags. And then there also is a section on custom transforms, and I'm going to be showing a little bit of a kind of a custom transform system that I tried to do. I thought I was being clever, but it turns out it didn't actually save me as much performance as I thought it was going to. So anyways, we can kind of go over to our sample project here. So by the way, we do have all these sample projects available on GitHub. Tobias, if you want to maybe pull up the link for that, if you just go to our GitHub organization and just get the link for this repository and paste it in the chat there, that would be fantastic. But we will have it linked kind of in the description after the live stream ends and all that. So let me see, is this the scene that I want to start with? I want to go ahead and start with a different scene, which is the spawn scene. So the idea with this spawn scene is we have a spawner here, and it's just going to spawn this stationary spawnee. If I go over to here, and this is not the spawn system I want. I have two spawn systems. Here we go. So basically I have 4 different methods essentially of spawning entities, and I'm going to be kind of showcasing the pros and cons with the different entities here. So the first one I'm going to show is just by spawning it using a local entity command buffer. This would be the same thing that we would do if we were just spawning with the entity manager directly. And what I'm doing in this case is I'm doing a local entity command buffer.instantiate, and I'm just setting the local transforms position on here. The way that I have this set up is that after I basically click the button, it's going to go ahead and pause the execution of the application, so we can kind of see a couple of the different quirks here. So go ahead and press the 1 key to spawn our entity. And you'll see that it goes ahead and just spawns this guy in the world here. And then we can go ahead and move over to the next frame. And then it just kind of is spawned in place there. So what I wanted to demonstrate with this is the pro is that it spawns in the correct place on the exact same frame. And there's no kind of delay or anything like that. The one con with this is it does create a sync point in the middle of the player loop. So that basically means that, it's going to kind of force all the other jobs to completion, and that could potentially be something that we don't want to happen. But in the case if you're just kind of spawning one thing every once in a while, it's probably not all that big of a deal. But if we are doing a lot of instantiations all the time, this is something that we'd probably want to avoid. The next method is where we're using the end simulation entity command buffer system. So the idea with this one is that now this is actually going to spawn at the end of the frame at a pre-existing synchronization point. So if I go ahead and press the 2 key, you'll see that this guy actually kind of spawns under the ground a little bit. And if we move over to the next frame, then it's going to go ahead and actually move into its final position. So the reason for this kind of has to do with like the ordering of when the transform system happens. So you can see that what we're doing here is we're setting the local transform to that position of 444. But what happens is that this end simulation entity command buffer system runs after this local to world system that we're just looking at, that basically takes the local transform and converts it over into the world position. So essentially what happens is the world position still thinks it's at 0, 0, 0 because that hasn't been updated, because we instantiated this entity after that system took place to actually set the local to world component. So you see in the first frame, it goes ahead and it actually spawns it with the correct local transform. So we could actually look at the local transform on that one frame that it spawned, and it would say that that's in the correct position, but you see that it spawns in the incorrect local to world position, and it's rendered at just whatever is the default position for that prefab. So that's not necessarily always what we want. So another option that you see that people do a lot of times is actually I'll skip over to number 4 here. So this is using the begin simulation entity command buffer system. Now we'll go over here. I'll press the 4 key, and you see that execution is paused, but we don't see any new entities. However, we move over to the next frame. I'm still paused from the last one. So now we're paused, and then we move over to the next frame. Then you see that it moves into view. So reason for this is because, at the end of the current frame, that entity hasn't been instantiated yet, and it doesn't even exist, so it's not there yet. However, it does get instantiated early on in the frame before that transform system runs, so that the first time that we actually do see it on the screen, it's in the correct place. So that's often a pretty good compromise, because it does use the existing synchronization points, but we just have that kind of one frame delay, which is often not that big of a deal. The last option that I have is again using the end entity command buffer system. However, this one, what I'm doing here is I'm also setting the local to world component on here. Now, this one is probably not something that I would always use, because if we say, press the 3 key, you see what actually happens is, when we pause on this first frame here, the actual entity itself is in the correct position. It's rendered on the exact same frame and everything like that. But you can see its glasses are still in the default position. That's because we're not actually setting the local to world on all the children. So it doesn't kind of cascade down the whole thing. Of course, we could manually go through all the children and set all the local to worlds on there, but that's just a whole bunch of extra code for not really all that much benefit. So then you'll see if we do go to the next frame, then the glasses snap into place and everything is gravy. So those are just kind of like some weird quirks about entity instantiation. I just kind of wanted to like bring that up a little bit, because there are different ways that we can go about doing different entity instantiation, and there are some pros and cons for each of these methods. But yeah, so Tobias, do you have any like kind of preferred method that you use for entity instantiation? Do you have any additional comments on any of this here?
Yeah, so this situation where spawning single ones like this are, I actually don't use that too much. When I use it, I guess I mainly use the first one, but not through an entity command buffer, because I usually do the instantiate with a whole entity array.
Oh,
and
okay.
that's through the entity manager, so you don't use a command buffer in between.
Nice.
I just I have a few places in the frame where I just spawn all the enemies that I need, or spawn everything I need, or all the bullets I need, for example, and I do that through explicit sync points, which I create sometimes. I have a few explicit ones. So I guess the first one, but there's a ton of different things that is one frame delayed in my game. That it's not exactly position often, but there's a bunch of stuff where end simulation and the command buffer system, that's a mouthful.
Right, I know.
Where that one is used, and as you said, in saying if it's something that is not connected directly to the input of the player, I don't care if it's one delayed frame. It's just
Right,
that the only thing I'm very concerned about, if you move with the mouse or you press a button and you want a frame, not something to reflect on the screen, that thing I have worked hard to make so it uses the first one basically, so it's
nice.
really updating straight.
Awesome.
Yeah, but I have on the third one, on the last example, that's if you scroll down to the setting the local to world thing at the same time, I have a slightly different thing there that might be a good sample point for the audience. So my enemies in the game, they
Oh
don't
yeah.
they don't care about any transform. They live in world space, and they live without any parents, and they don't care, and there is nothing underneath them because they're completely GPU based, shader based, animated. So they don't need any sub entities to follow them. Generally speaking, there are a few certain cases, but generally speaking, they don't have anything under them. So just a single entity, and they don't have a scale or anything like that, where they have a completely different type of scale thing. So I don't even have a local transform on them. Like three of my enemies only have their own flow 3 position that I have done in my own component, and a few of them have their own rotation as well, or all of them have rotation, I think. So, and I just work with that rotation and position in my code completely, like devoid of anything else that, and compared to the player or whatever, like are you close or are you far away, and you don't need really the local transform for that because they're not part of a transform hierarchy. And then I set the local to world in my code strict away, but since I don't have any local transform on it, there's nothing else setting the local to world. So I'm alone in my code putting out the
Right.
actual
You're taking over
global
responsibility for that. Yeah.
rendering position. Yeah, and since there's no child object under my enemies, it doesn't matter. I just write to it and it's just fine. So you can, there's a bunch of situation, and as data oriented design go, do we need the data? Maybe not. Maybe we can just throw this out. So I don't need the scale because I use a completely different situation for my
Right. Yeah.
enemies. So then you can just throw out a few floats and work directly with the data you need. And
Exactly.
yeah, so that's a fifth way, I guess, which is more or less like this, like the third one.
Nice. Yeah, so for me, I typically like to go with the begin simulation entity command buffer system, though. Even though it doesn't spawn on that one exact frame, it kind of avoids the thing with creating an additional sync point. But you also don't get that issue where it appears at the origin for like one frame and then spawns in its correct location, because that is something that you can notice. As the player from that one frame delays, you can actually see, if you're near the origin, you can see it flash at the origin. And then, that's not necessarily a good experience because you see like, oh, did something just like pop in and then pop out? Like, what the heck was that? But, when you have that one frame delay where it's just nothing on that first frame, but then it just spawns where it needs to be on the next frame, then that's, no problem for the most part for me. Okay, so moving along, the next thing that I wanted to do, actually created a little bit of a diagram here for the player loop. So this is just kind of like super hacky version of the simulation system group. I cut it GRUs. What is that? That's what happens when you're typing something late at night. So basically, this is just kind of like the player in the player loop. There's kind of like the three main sections. So the middle section is the simulation system group, where like most of your gameplay logic is happening. So what I have here is like kind of towards the beginning, you're doing your own kind of transformation logic. So you're kind of like, manipulating the local transform and things like that. And then, at some point, you probably know that you're done manipulating the transform, but you still may have some other logic that kind of takes place. And then next up, you have the transform system group, where Unity kind of takes over and does that automatic conversion of the local transform into the local to world. And then kind of towards the end, you have some of like your other game logic, just kind of other miscellaneous stuff. So what I wanted to showcase with this is how if you had like, say, maybe like a UI element that you want to follow the position of another entity, or you wanted, maybe you have some like camera target entity that, needs to match the position of the player or something of that nature. With this, I wanted to show, where you are kind of like safe to set that value for that particular entity. So you don't want to do it kind of when you're still potentially manipulating your transform, because of course your local transform could get updated later on in the frame. So then you could still potentially be using old data, or maybe even like temporary intermediate data where it's like, not even, ever was a valid position. And same thing with the local to world. This is going to have the data from the previous frame still at this point. So you don't want to be doing it kind of like early on. At some point, you kind of may just like know your code well enough to know like, okay, this is the last system where I'm updating my local transform logic, and I'm not updating local transform after that at all. At that point, then you're pretty safe to, key off the local transform. You can say, oh, okay, that, I know the position is here. That's what it's going to be rendered at eventually. So I can go ahead and, use that there. However, you still don't want to use the local to world because it hasn't been set by that transform system group yet. So it's still at this point going to have data from the previous frame. So then the transform system group runs, it goes ahead and, sets everything in the local to world. So after that, you're totally fine using the local to world to say, hey, this is where the, position and rotation is. Let me go ahead and, key off that and do whatever I need to do. You can also use the local transform as well, but I will just say, be cautious, because at this point, you could potentially be manipulating the local transform in some, random miscellaneous system. But that the data in, that local transform, that is not going to be copied over to the local to world for this frame. So, even if you manipulate that transform, it's still, the entity is still going to be rendered at whatever that local to world is set as. So kind of just wanted to demonstrate that. Did that make sense?
For me, it makes a lot of sense. Yeah. And I'd just like to point out that this is the way that I think, through my experience, most game engines or most situation work. This is how you do it. But Unity traditionally, if you use the old system transform, actually, if you take out transform dot position, the old type transform, then you do all this calculation exactly on that line, which make it really not performant. So we sort of trade the simplicity from the old type of transform system that Unity uses in the old traditional for this, where you need to be more firm with where you do stuff.
Right.
But you trade it for better performance because you don't mess around with the whole transform hierarchy every time you touch anything.
Right.
Because if you touch the anything in transform, sometimes you just get a whole cascade of recalculations of it, which is kind of weird.
Right. Yeah. So it is a performance benefit, and also we do just have kind of like more control. We can be more specific about, where things are happening, and maybe there are some circumstances where we want things to happen at certain places. So again, just a lot more control over that. Yeah. And I should point out that actually, what you just mentioned there does bring up a good point. There is a way where you can use the local transform and do I believe it's like a dot compute world matrix or something like that.
Yeah.
It actually is a pretty big, function call. You gotta pass a lot of variables into it, because it actually does that whole like, parenting hierarchy calculation of, going through all the, parent entities and everything like that to figure out, the exact world position of that. So, that is something that you can do at any point. You can take that local transform and you can figure out, what that local to world will be. But just be aware that there, could be some, that could be quite expensive. So it's, again, not something that you want to be doing all the time, but if you need to do it every now and again, that's no problem. Okay, so we have that. And then, the last kind of demo that I wanted to showcase here actually has to do with some parenting stuff. So we'll go over to the samples project. The scenes, and I have this parent scene here. Okay, so with this one, we're going to be doing a little bit of kind of performance analysis. We're going to be spawning a bunch more of entities here, doing some fun ECS related stuff here. So what it's going to be doing in this case is we're just going to go ahead and spawn a bunch of these guys. So we're spawning 250 by 250. You can see right now we're moving all these guys at around 50 frames per second. So, and basically what these guys are doing is, if we kind of zoom in here, they're just kind of like randomly moving around. So they'll just pick like a random direction to move in. They'll face that direction and then just move forward. And then, every couple seconds, they'll just kind of like recalculate their random direction. So it's just kind of some random movement. So we can just kind of like test a couple things with the transform system here. So if we look over in the entities hierarchy, you can see what we have here is these guys, all these spawnees are just kind of at the root here of the scene. And then so one thing that, people might do, and this is kind of going back to when we're looking at that forum post, talking about some like naive things that somebody might potentially do, is say, oh, I have, all these entities here. Let me just kind of clean things up and we'll put these all under a parent. So if we go over here and then we say should parent, so this is what this is going to do is if we enter play mode, you can see, oh, awesome. Look, all these guys are just under this one parent. This is so much nicer and cleaner. We can actually go ahead and we see, oh, we got all these spawnees. But oh my gosh, look at this. We're down to 15 frames per second now. So we have, absolutely cut our performance in, just a fraction of what we had before, just by simply putting all these spawnees under the parent. So the reason for that, if we take a look at our profiler here, you see that if we look in the jobs here, you see that we have a whole bunch of idle threads for a long while, and then we scroll down, 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 and we have this local to world system compute child local to world job happening all on one single thread here. The reason for this is because when we have that one single parent, if we actually kind of go into the local to world system, and what was this called again? The compute child local to world job. So this is compute root. So yeah, compute child local to world job. So basically what this does is we basically get a dynamic buffer, and then we go through linearly all the children, and then call the child local to world from transform matrix on here. So we have to, update all these children one by one manually on one single thread here, basically just going through that buffer of all the children and updating the transforms. And again, all this stuff has to happen in that one thread, because we're just going from the parent, going through that dynamic buffer, and then iterating through each child and updating the child's transform position. So, as you can see, what we thought of just like, oh, hey, I'm just doing a little bit of scene cleanup here just by putting everything under this one parent. Well, that actually leads to some massive performance implications, because, now we have to go to this parent and we can see that we have this child buffer of 62,500 length of all the children on here. And so, yeah, it's definitely a potential issue that you could run into. So I'm just saying, you don't want to necessarily avoid using the, parenting hierarchy. However, don't overuse it to the point where you have like many entities under one single entity, just to kind of do a little bit of scene cleanup and maintenance there.
Crazy, very crazy.
Yeah.
Just to quick callback to my quick tip here with the child dynamic buffer. That's an excellent use case for the to native array and reinterpret entity. So if you have a bunch of children and they're not going to change, you just want to use the data straight up in a job really unrelated almost, and you might do a bunch of structural changes or whatever, you can just reinterpret that to entity, so you get all the children flat as an entity array, and then to native array, and you get a copy of it, and then you can work with it however much you want. Right. I don't know, maybe they're doing something like that.
I was gonna look. It doesn't look like they're doing it here, so maybe they should hire you.
but that's because, and this is actually like sort of, I think this is probably a trade-off, but probably that they're doing it because they are on the actual parent entity working, right? So they don't need to worry about, because they're on the
Oh, yeah,
owning
yeah, yeah,
entity
yeah.
already and working.
Right.
But that's also like goes back to this performance issue, because they are on the owning entity. They're sort of stuck on that single one with this single thread. And when you put this 65,000 underneath it, then if you were to turn it around, maybe you can split it up and then have this copy of the child entity array and just spread it all over the different threads. And you can do it the reverse sort of update order, or the reverse access order. But yeah, that's a little bit too much in that. But anyway, I use it a lot, the children, to a copy of the entity array to make it easier to work with the children of something. So that's
Nice.
a
Nice.
yeah.
And then, so let's see, there were kind of some other things. One thing that I don't know if we need to get into this too in depth here, but we actually kind of brought this up on last week's episode where Danny was saying leg, but he meant linked entity group. I don't know if you'd caught that. So I have this add leg checkmark box here. So basically what this does is, and actually let's just go ahead and do a little bit less of these, just so we can have a little bit of better performance here. So with the linked entity group, basically this is just kind of like another buffer. So if we look at the parent here, so we have the child buffer, but then we also have a linked entity group buffer. And so this contains all the children, but also the parent itself. And so with the linked entity group, now I have these options in here where we can say disable just the parent, and that actually goes ahead and disables all the children objects. But I did notice one thing is it doesn't disable the children's children, so the glasses are still all enabled here, which I thought was kind of interesting. So then if we re-enable the parent, then all the children get re-enabled as well. Now, interesting thing to note is I believe if we go to, no, never mind. Yeah, disabled is disabled. It doesn't update the transforms or anything like that. And then also the other kind of main thing that linked entity group is used for is for destroying. So if we destroy the parent, then it destroys all the children. And this time it does destroy all the children's children as well. So just, yeah, a thing to point out on the linked entity group. Oh, and I guess I should have showed, I did say that I was going to show this earlier. We actually look into how we're spawning these. You see that the way that we actually set a parent is all that we need to do is, yeah, go here. So if I have this like should parent set, then what we do is just on the child entity, all we need to do is set the parent component equal to new parent. And this sets up a bunch of things for us. So basically what this is going to do is, if we just look at one of the spawnees, it goes ahead and sets the, that's previous parent. Where is this, the regular parent? Oh, right here. So yeah, it sets the parent on here. This child comes from the prefab, so that's just kind of something automatically done. But it also gives us a previous parent, which kind of detects some changes between any parenting hierarchy. Doesn't do anything else on the child entity, but it does automatically add the child to the child dynamic buffer on the parent. So a lot of that stuff is kind of taken for us, or done for us. The linked entity group is something that is not manually done for us. We do have to kind of manually populate that. So that was just what I wanted to point out on that. And then I think the last thing that I wanted to showcase was kind of also in here. And this is kind of my custom transform system that I tried taking a stab at here. So we'll go ahead and change the prefab out for this cube. And we'll do this. I think I was doing 500 by 500. Let me see if that looks right.
compiling shader, so it might be.
Yeah, I'll do. I just want to see kind of what the performance is at about.
There you go.
Oh, they're all over here. So I can add a little bit more spacing between these. All right, that's fine. So actually I should do without this. Okay, so what this is doing here, this is doing it's running like the exact same code, but I'm just using these different cubes here. So you can see there's just kind of doing the same random, it just picks a random rotation, moves in that direction, and every couple seconds they'll change up. So you see here that we're running around like 80, give or take, frames a second here. So pretty decent with, how many entities are we running this against? 62,500. So you can see that the local to world system, so we have the random move system processing all these, and the local to world system is processing all these here. Now, there actually is a way that we can say overwrite the local to world system and use kind of our own local to world system. So what I've done here is created this turbo local to world tag. And so what this does is it has an attribute over this component, and this is just a empty data component, and this has a tag of a write group, and then we pass in the type of local to world. Now, I did on the channel a while back do a video on write groups. Pretty much all of the theory for write groups exists the same as that video, but just some of the code might be a little bit different for the particular implementation details. The idea with write groups is that they give us the ability to kind of override existing logic. So again, if we go back to the local to world system and we scroll down to where we're actually like creating the queries that we'll be scheduling against, you'll see that one of the options that we add is the entity query options.filter write group. So this essentially means that if an entity has a component that targets a write group that is kind of part of that entity query, then this entity is going to kind of ignore that system. So it's almost another way of just kind of like filtering down our queries a little bit further, so we can again have a little bit more control over our logic. Now, admittedly, write groups aren't necessarily something that you're going to need to use a lot. So if you don't completely understand it at this time, that's totally fine. But basically, what it allows you to do is you can do something like this, where I have created my own turbo local to world system. And instead of kind of doing, all this stuff in the local to world system where we're kind of like, doing some checks and balances to see if it has like a post transformation matrix and, if it has any children and, do we need to apply any rotations and things like this. I just did a much simpler implementation of this where I basically just kind of created kind of this like basic float 4x4, and you see that it uses it's kind of like similar code to what we were looking at before, where I create a float 3x3, but instead I'm just passing in quaternion.identity. So I'm going to say, hey, let's not rotate this at all. We're just going to use a scale of 111, and then we'll go ahead and create this float 4x4 matrix here. We can go ahead and actually schedule an iJob entity, and then you see that what I'm doing here is I'm just setting the local to world to that, and then I just need to set the C3 to a new float 4, and I've just passed in the transform.position and a value of 1 here. And so all this is doing is just updating just the position. So the rotation and scale should all just kind of be default here. So if we come over to the turbo transform cube and I add the turbo local to world authoring, you see that when I enter play mode, a couple things that you'll notice is, number one, you'll see that the cubes, they're basically all just at kind of the default rotation. They're still updating their transforms and everything like that. But if we look down in here, you'll see that the local to world system is now running on just two entities, just kind of some default entities that we have here. But the turbo local to world system has that full 62,500. So again, I thought I was being super clever and trying to sidestep the existing local to world system and make something much more efficient that doesn't have to do a lot of the extra stuff that the local to world system was doing. But looking at the performance results, they're pretty much the same. It's just hanging right around 80 frames per second. So that actually pretty much had no impact on performance. So it was a fun little exercise to kind of go through and figure out some different ways that I could, again, potentially sidestep some of the calculations that are being done there by doing something a lot more simple. But it turns out, I guess, the local to world system is just pretty dang efficient and works pretty well, actually. So, yeah, that's kind of what I had for the instruction set. Was there anything else that you kind of wanted to add on there?
No, I can add that you are using the position here to update the position, the position from the local transform object, right?
Yeah.
You just skip the full transform set.
Exactly, yeah.
Yeah,
Yeah, I'm
and
not using the transform.to matrix. I'm just pulling out the transform and just setting that, last column of the,
So it's in a way it's kind of similar how I do all the enemies in my game, because I don't need to use the right group because I don't even have a local transform, since I have my own position and rotation defined in my own component. So when you remove the local transform, you sort of also do the skipping of the whole transform system. So it's a very very similar thing. But if you want to do what I do, but you still want to use the local transform object, then you use the right group to I still want to use the Unity built-in stuff, but I just want to write the position update thing myself. Then,
exactly.
Yeah. So it's conceptually kind of similar. It's just that I sort of sidestep the right group because I just put everything into my own component instead.
Right.
Yeah.
All right. Well, now we're at the kind of Q&A portion of the show. So feel free if anyone has any questions that are related to anything that we talked about here. We can go ahead and bring this up. I do see that we do have one from Wayne Games that you had starred here. So it seems to support non-uniform scale with 11 floats, from what I understand, 4 for rotation, 3 position, 3 for stretch, and 1 for scale.
So I actually, you need the other one over. I forgot about that one. He's talking. I looked it up a little bit earlier. He's talking about probably different from that dreaming guy. I can't even
Dreaming
pronounce
I'm Latios, I believe.
Yeah. That guy is a sort of famous person
Yeah.
at the Unity Dots forums, and I think he made a bunch of different code structures, open source and stuff. And QVVS stands for quaternion vector scale, I think, and it's like the rotation, the position, and some shear or something. I think they stretch, and then 1 for scale. So it's like something about maybe you can if you just put in flow 3 into we have the normal one, that local transform, where we have the quaternion, the position, and the scale. But if you just put in a second flow 3, you can sort of get in the post transform matrix or post non-uniform scale, I think, into it, because you have another flow 3 that you can sort of apply in the end, instead of having the post transform matrix which Unity provides, which is the full 4x4. I didn't look up if it's exactly what's going on, but I would assume that's sort of what's going on. And he just asked if that was something we have looked into, and I haven't. Have you heard about this?
No, I haven't.
Yeah, so I would just assume that it's basically just building in the post transform matrix thing into the local transform, so you have everything in the same again, but you're reducing the complex 4x4 scalar into just a three vector thing, where you can do the X, Y, and Z scaling like normal. But you still have, the single scale thing for the hierarchy. This thing is just for the end scale when you're just presenting it. So it's yeah. I think you should probably Google that. I mean, the viewers should
Yeah,
probably
yeah, yeah.
Google
I will
that
look
if
it
they
up for
want to look
sure.
into it. I have never had any issues with the current situation, so I haven't had to look into that framework that he's talking about. But yeah, it looks like it just takes 3 more floats per local transform, and it lets you do a bunch of other stuff with it, which probably a trade-off some games need.
Yeah, cool. That sounds great.
Yeah.
I also see Jeff says I miss transform aspect. I think that was kind of it seemed a lot more useful when Unity had like the separate transform components. Like there was a separate position and rotation and scale components, and the transform aspect is a way that we could kind of access and manipulate these all just from one single place. But now that they kind of switched over to having the local transform, it doesn't seem to make as much sense as the transform aspect did. But did you ever use the transform aspect when they kind of like came out with that initially?
Yeah, I was right in the middle of when they was necessary before they moved into local transform. I was in there for like half a year, I think, but I don't use actually the aspects generally speaking, because you can aspects anything basically, but I don't use it because most of the time when I would need an aspect to combine more states and more components, it usually is a good way for me to realize that maybe I'm splitting up things a little bit too much, and I can squeeze some components together into single component. That probably not is not the case for bigger games, but for my game, I rarely need to put several components into a single aspect for convenience sake.
Makes sense. Makes
Yeah.
sense. All right. Well, I think that looks like about it for the Q&A that we have. So after that, we can kind of start wrapping things up here. So we'll do our dynamic allocation. This is where we kind of just bring up some fun things that we want to share with the community. So I'll go ahead and go first. What I'm going to be sharing this week is a talk by Casey Muratori, actually somebody who, I know both of us follow pretty closely in a lot of the things that he does. He kind of does a lot of the performance-aware programming is what he calls it. So I just went ahead and linked this video in the chat here. So this is a talk that he gave called "Killing the Walk Monster," and shout out to Casey. He actually gave this talk at a conference a number of years back, maybe like 2018 or something like that, and the audio quality from it was like super bad. Like you can still find the original. Out on YouTube, the original talk, but the audio quality was just not that good. So he actually re-recorded the talk on his own, and so this is that re-recorded, kind of remastered version of the talk. So, anyways, it's a super interesting talk where he basically talks about how he created this tool for the video game The Witness. So he's close friends with Jonathan Blow, who is the lead developer of The Witness. And so Casey basically created this tool to essentially test in real time the character controller. So it kind of shows, like, gives you like essentially a map of like all the valid positions that a character can go at any given time. And this is just like super helpful for like level designers, so they can kind of have this tool enabled as they're setting things in the world, and so they can see are players able to get to a specific position, and a lot of like really interesting things like that. And I think this talk does just like a really good job about like showing some complex problems in game development and like some cool and interesting ways that people go about solving them. And what they came up with is a pretty much bulletproof tool, so that like what they came up with is this character controller that no matter how hard you try in The Witness, like you cannot clip through geometry, go anywhere you're not supposed to go. He actually even shows at one point in the talk where he like increases the movement speed by like 150 times, and he's just zooming around the world, and he's still not able to, clip into geometry and jump over things that, you shouldn't be able to. So I think it's just a super interesting talk. So would highly recommend it.
All
And
right.
then, yeah, Tobias, what is your dynamic allocation for the week?
Yeah, so I was part of the Global Game Jam this past weekend with a few friends of mine. And we made a very weird game because the theme was Make Me Laugh. And yeah, I can't really tell anything about it because Johnny's going to play it live for the first time here. It's just like a few minutes
Yeah,
experience. And I'll leave a link here from my
yeah.
personal account. And you should just, yeah, do full screen, and then I can take a few words about it. And when you do it, you don't need to like whip around the camera as much. If you're most of the main things that going on is going on where you imagine they would be going on. So just for the
Okay.
audience, you don't need to be whipping around and looking too much everywhere.
Okay.
That's the only thing I can prepare you for.
Sounds good. Well, yeah.
And
So
then
we're
audio if you can.
okay. We'll
Yeah.
do. Yeah. So yeah, I'm gonna play the his game at the end of this. But we'll just go ahead and kind of wrap things up. But actually, before that, I just kind of wanted to ask about your kind of experience at the Global Game Jam. Like, how'd it go? Did you guys have any fun stories for development stuff during the jam or anything like that?
No, it went pretty all right. This is not using dots, obviously, or obviously not, maybe obviously, but it's just too quick. It's not necessary to care about dots. But I just threw everything. I was the only programmer, and I just threw everything at the wall as fast as I could, and it worked out in the end. And it's a ton of fun. If people haven't done game jams, they should. It's super fun, and you should just find. You can do it yourself, but you should just find some people who want to work with you. And we were two graphics designers or whatever, and one designer, one audio person, and then me as a programmer. And we worked for it for basically 2 full days, all in all. And yeah, no real problems actually, because it's just very much vanilla Unity for me, and I worked with that for more than 10 years now. So it's just a highway straight onto the goal with this one. Yeah,
Awesome.
that's
Well, I'm yeah very much looking forward to checking it out. You haven't told me anything about it, so I'm going in completely blind. The only thing that I know is it's called a Nip for Speed, which I
yeah,
think is a funny name. So make
and
me
it's
laugh. I mean, you're off to a good start there.
yeah, it's nip as in catnip. Yeah, so
Thanks for
that's it.
clarifying.
Yes.
So yeah, anyways, we'll go ahead and just wrap this show up real quick, and then again, I'm gonna just be playing his game on the live stream just right after we finish up here. So real quick, I just want to go ahead and give a major thank you to our top tier Patreon supporters at the CPU registered tier. So thank you very much to eCool for being our supporter over there on Patreon. Once again, everyone can go ahead and go over to Patreon at patreon.com/turbomakesgames, where you can support us over there. We have a lot of cool perks for the different levels. So you can get audio only feeds of this episode. All patrons get access to the monthly bonus show, and there also is some voting rights, and you can vote on the current show, which we have up right now, or the bonus video for the month of February. So a lot of cool stuff over there. So go check it out if you want to. And then, so yeah, with that, that's basically going to be it for the Hot Path show. So Tobias, this was your first show. How'd it go? How'd you feel?
Good. Yeah, fun. Yeah. I'm all for it.
Awesome. Sounds great. Well, thanks everybody for joining us here today, and then join us next week, and we're going to be back next Friday, and got another exciting episode cooking up for you guys. So anyways, with that, I'm going to go ahead and switch over, and I just play this in the browser, right?
Yeah, and make sure it's full screen.
Okay. So
I think the magenta full screen button is the one that makes it properly.
oh yeah, because there's like the two
Yeah.
full screens on itch.
Yeah.
Okay, so we'll run experience, and then so you
Yeah,
think it's
that one. Yeah,
this
it
one?
is that. Yeah. Yeah, it should be just to push it. There we go.
Okay. Press to start. We have a bone and a revolver. What is the bone? Okay, so I can use the scroll wheel to spin around. Very good. We'll return it. We have the revolver. Can also spin that around.
Meow.
Hey you're finally awake. You really went on a bender. I'm going to get some burgers. You just hopped in and tagged along. Nice with some company. We have a cat driving.
Meow.
It's going pretty slow and I don't want to stretch out the gear shift. Could you please shift the gear for me? Don't worry about the clutch. I glued it to the floor. Alright, change the gear. That's nice. I've never done this before. Oh well, it's hard to tell when the speedometer is broken, but it feels fast.
Meow.
You're not very talkative. It's rather awkward. Could you please turn on the radio?
Meow.
Oh man, I love this album. Glenn and the boys always making such great music. Truly one of the greats. It's like a mix between catching a mouse and demolishing the Christmas tree.
Meow, meow, meow.
He's waking up as well. I need to up the dose next time. Quick, shut him up before he grabs attention from the cops. We'll get the woof, so you get the bone.
Meow,
Bone.
meow, meow.
Good thing you didn't try to shoot him. That would have been pretty gruesome. Besides, I ran out of bullets, and you would have seen your act of betrayal and been very sad about it. What happens?
Meow.
It's autumn night. Always gets me so sentimental. Mind grabbing the cig for me. Alright, where is the cigarette? Oh, is it probably this? Pick up lighter? No. Is it? Yes.
Meow, meow, meow.
Okay, you light it. Got the light. Oh yeah, that's the stuff. I wouldn't mind having a passenger princess like you around more often. Seeing all the odd traffic signs outside, almost like we got our licenses in a cereal packet. I haven't been paying attention, but I did see one said cocaine.
Meow, meow, meow.
That's the cops. I know what I said about the gun earlier, but I lied. It's very much loaded. Give it to me quickly.
Meow.
Good thing I saved that bullet. My catnip is safe for now. And remember, you saw nothing. Got it?
Meow.
I'm thirsty. Grab me a can from the back seat, will ya? This cat.
Meow, meow.
Oh, that's about the best sound in the world. Give me a sip of that. Gotta love. Tuborg 5.2.
Meow.
It's warm with all this fur. Can you please roll down your window? If I roll down mine, I'm afraid the dog would just absolutely stuck their tongue with it. Ah, yes, the cool night. It's amazing. I'm glad you're along for this ride with me.
Meow,
Do
meow,
not turn.
meow.
Remember, children, seatbelts save lives. Such a goofy game.
Yes. Everything was just weird, and we tried to make the weirdest thing we could imagine.
That was very weird. I enjoyed it very much, though. Nicely done.
Thank you. Yeah. All right.
All right. Well, I guess that'll do it for this live stream here. So, yeah, once again, thanks everyone for joining us, and tune in next week for another exciting episode of the Hot Path Show.
Nice.
Later, everybody.
Bye.